Hello, welcome. So today we are going to cover a very important topic, which is pull up and pull down. And this is very common when you are designing a microcontroller based circuits or any digital circuit. So this is a very important concept for understanding what is pull up and pull down. Just see these circuits where I have a microcontroller and a receipt pin is connected to 5 volt or it can be 3.3 volt through a resistor which is called a pull up. What is pull down then? So some other pins, take example, some other pins which can be connected to ground through a resistor which is called pull down. So in this tutorial, we'll try to understand what are pull up and pull down, why they are important, when to use it, how to calculate the value of these resistors. We'll cover all these topics. So let's say that you have a microcontroller and you have configured the pin as a input. So you have a pin A1 of a microcontroller which you have a configured as an input, and your program reads the state of this pin. Then will it be high or logic low? It is difficult to say. So that phenomenon is called a floating state, or you can say that the state is not unknown. So to prevent this unknown state, a pull up and pull down is required so that the pin will be configured as a low or high initially. So that is called pull up and pull down. Now there are some points that you need to understand. So how to understand that what value of resistors you need to keep it at pull up or pull down. So for this, I will just focus on pull up because pull up and pull down, I see the concepts are same. Only the difference is in pull up you connect the resistor to either 5 volt or 3.3 volt. In pull down you connect the resistor to a ground. So we'll focus on pull up only in this session. So let's suppose the button is not pressed. Okay. So in these situations, what happen? Uh, this pin will be read as a high, and there will be very small amount of current that will flow through the input pin, and this voltage will be approx to whatever VCC only. But when the button is pressed, what happens? The pin will be read as a logic low, and the current will flow from VCC to R1 to this button to ground. So that is the condition when button is pressed and button is not pressed. Now how to decide the value of R1? So there are points, right? So what I explained that when the button is pressed, right? So this value R1 value will control what amount of current will flow through VCC to R1. So that is one point you have to remember, right? During press conditions, R1 will control what amount of current will flow, and when the button is not pressed, so some amount of current will flow, but the R1 will decide what the voltage will be at the input, right? During unpressed conditions. So these are the things the R1 should satisfy, okay, during pressed and unpressed conditions. And also one more thing I would like to say. So whatever system, right, that is feeding to this input pin, so that is mostly a capacitor couple, right, and that will form one RC filter. And you know that the RC takes some time to charge and discharge. So it takes some time to charge and discharge. Now when you are using a pull up on a very high speed signal let's suppose that signal is changing very fast and it is a USB. So if you keep a very high resistor value, so that may limit the speed at which the input pin will change its states. So mostly we will see on the USB lines, right? The pull up are the value from 1 kilo ohm to 4.7 kilo ohm. So that all points you have to take care of while deciding what value to keep. Now I will just take one example of how to calculate the value of the resistor. So where is my okay? So let's suppose the VCC is 5 volt. Okay, I am considering same circuit. The VCC is 5 volt. Okay, and it is the button now you also want that when the button is pressed, right, you want to limit the current to 1 milliampere only when the button is pressed. Now you can use a simple ohms law, which is V is equal to IR. Very simple. So V here is 5 volt. Okay, and then current you have I already mentioned you want to limit the current to 1 milliampere only when the button is pressed. So from here R comes out to be 5 divided by 1, which is nothing but 5 kilo. So this is how you calculate the pull-up resistors value. Thank you. Please comments if you have any query.